Hey there, I wanted to come back and look at this example that we had done in the previous video because I forgot to write the answer in scientific notation. So I just wanted to make sure that we knew how to do that. So we were going back to the example with the pH of milk. We saw that the pH is 6.5, and so we are going to use our formula for the pH, and we want to find the hydrogen ions. So we put in, right, 6.5 equals negative log of the hydrogen ions. So divide by -1 and then undo the log. So how are we undoing the logarithm here? The thing to remember is your definition of a logarithm, right? You have log base b of a equals x means b to the x equals a. So in this case, when you don't have anything there, is 10. So log base 10, so the base is 10, the exponent is -6.5 equals the step inside the log. Now here, I just kind of left it here, but in WebAssign, you're asked to write it in scientific notation. So how do we do that? I probably left it because I thought our scientific notation is fresh in our minds, but it might not be. So let's do it out. So you will put it in your calculator, and your calculator will pretty much already give you the scientific notation. So let me bring in my calculator real quick. And so when I bring in the calculator, so we want to do 10 to the -6.5. So I'm going to go over here to my 10 to the power, so 10 to the, and I want to use the negative. Make sure you don't use the minus, the subtraction symbol. You want to use the actual negative. So negative and then 6.5 and hit enter. And so I get 3.1623 to the -7. So that is what I'm going to then write over here. So 3.162. So I'm going to say here, right, this is 3.1623, I think is what we said, times 10 to the -7. Usually you'll just round to one decimal place. So then I will say, then this is 3.2 times 10 to the -7. And so this will be my actual scientific notation. So with scientific notation, the exponent has to be an integer. So when I have -6.5 here, that is not acceptable. So we have to write it in scientific notation, meaning you're going to have a times 10 to the an integer, either positive or a negative integer. So no decimals, no fractions. So that was the part that I left up. How do you take this and write it in scientific notation? So in WebAssign, this will be the answer that you would put in. And pay attention to what decimals they want you. So to one decimal place, two decimal places, because that could also affect your answer. And so I did an example of, given the pH, how do you find the hydrogen ions, the hydrogen concentration? But what if you're given the hydrogen concentration and you want to find the pH? Calculate the pH. So in this case, we're given the hydrogen ion concentration of a sample of tomato juice is 3.2 times 10 to the -4. Calculate the pH. So we're going to take our formula and plug it in there. So pH, our formula is that the pH is equal to negative log of the hydrogen ion concentration. So in our case, we want to find the pH. So pH equals negative log of the concentration. So it will be of 3.2 times 10 to the -4. And you will put that into your calculator and see what it equals. So let me bring in my calculator again. Clear this. So we are going to have, what was it, negative? So again, use the little negative here, not the minus, right? You're not subtracting. And then log is a log base 10 of, and what did we have? It was 3.2 times 10 to the -4. So 3.2. And you can either use, as I had mentioned in my previous video, the double E for the exponent, or you can just do, right, times and then above the log 10 to the, and then we want to put a negative for it. And again, the little minus here for negative number rather than the subtraction. If you put in the subtraction, you might get an error. And so I get 3.49485. So that will be my pH. And again, pay attention to how many decimals you want to round to. So here I didn't say, I think in WebAssign probably tells you to round to 3 decimal places, so it will be 3.495. And so that will be our pH. So when it's just calculate the pH, you plug in your hydrogen ion concentration in there, take the logarithm base 10, multiply it by negative, and that's it. Is when you're going backwards for the given the pH, then you have to use the logarithmic function definition to go back to it and then write it in scientific notation. So put in your calculator, and their calculator pretty much gives you the scientific notation. You just have to figure out what are you rounding to. And I'll do one with the intensity also for the decibel level. So let me find that problem. All right, so in my previous video, I did an example of if you're given the intensity level, how do you find the decibels? And so that was what this example was. So what if you're given the decibel level though, and you want to find the intensity? So let's look at a problem like that. And the thing to remember is our formula. So the decibels is given by 10 times log of the intensity of the object that we're looking at in I naught, the reference intensity of a barely audible sound. So this is standard in this formula. So you don't even have to maybe write I naught. You can just already write in the 10 to the minus 12 in here. And so I think in the example I wrote it as 1.0 times 10 to the minus 12, so we can do that. So that is kind of like standard to the formula, so that's going to go in here. So let me copy it for the example that I'm going to do. Actually, I'll just rewrite it. So here's our example. If earbuds are used with an MP3 player that has a decibel level of 90 decibels, find the intensity and round your answer to 3 decimal places. So let me write the formula. All right, so here's the formula. And like I said, this is standard to our formula for decibel, so you can already substitute it always. All right, so for our particular problem, it says if earbuds are used with an MP3 player that has a decibel level of 90, we want to find the intensity. So this is, we're looking for I when dB is 90. So this is going to look like 90 equals 10 log of I, this is what we're looking for, we don't know what it is, over 1.0 times 10 to the minus 12. So how do you solve? Our goal is to solve for I, so we want to isolate it. So divide both sides by 10, right? This is being multiplied, so divide both sides by 10. 90 divided by 10 is 9. And I'm going to have log of I over 1.0 times 10 to the minus 12. And now you can either use properties of logarithms here to expand this out, or we can actually use the definition of our logarithm again, right? I know that log base b of a equals x means b to the x equals a. So here, when we don't see a log, that's assumed to be base 10. So I can say then this is 10 to the 9 equals I over 1.0 times 10 to the minus 12, which this is just really 10 to the minus 12. And so multiply both sides by that. So you're going to have 10 to the 9 times 10 to the minus 12 to get rid of it from the denominator equals I. And so when you multiply the same basis, you add the exponent. So this becomes 10 to the minus 3 is the intensity. So what is that? 0.001, right? This is 1 over 10 cubed, which is 1 over 1000, which is 0.001. And so that will be the intensity here. And so that's how you find it. So now I think I'd cover the forwards and backwards. So when you're given the decibels, how do you find I? When you're given the intensity, how do you find the decibels? So hopefully this is a little more helpful. And I think my first video, I just did it with showing examples of going one way. And I wanted to do a little bit more with scientific notation. Email me if you have any questions.